In this episode, I'm going to look at a classic vintage GE clock radio. This is a model C4390. It features 4 vacuum fluorescent display tubes on it and an AM/FM radio. And the clock display is weak. So we're going to take a look at this and see whether it's the tubes that are bad or whether there's a problem in the circuit. Let's take a look at this classic. I had a viewer send me this General Electric model C4390A walnut grain. And it's quite heavy, this unit. It's a clock radio, but it uses, look at the indicator tubes, it uses fluorescent indicators, and as you can see, it's really dim. Even when it's turned up all the way, it's really dim. Now, I don't know whether the fault on this is the actual vacuum tubes, the fluorescent tubes that have failed, or whether we have a power supply type problem, because obviously incorrect voltage to the tubes is going to cause them to be weak. So I'm going to open this unit up and we're going to take a look and see whether we can get this one restored. It says here, the top is provided with an interlock, and to service the readout devices, remove the top by removing the center and 2 rear screws. So there's just the 3 screws here. I guess that's the 3 screws that have to come out to open this unit up. Okay, there it is. And it does have an interlock on here so that it shuts off the power when you take the top off. So this has got, these are vacuum fluorescent tubes on this unit. And they're in like a, that's interesting. I've never seen this done before. Check this out. It's like a screen that's over these. This is the filter to cut out the glare so you don't actually see the tubes. You see the light coming through them, but you don't actually see the phosphorus. Instead of having a colored plastic in front of it, it's got these. It's like a mesh type cover on it. And of course, now that the thing's unplugged, I have no power, so I'm going to have to hook this up with my cheater cord. So there's my poor man's cheater cord. We give this unit some power, and yes, these displays are actually very dim. But I have to do some voltage measurements here to make sure that the tubes are actually getting the correct voltage. I removed the other 2 screws in the front so that I can lift the bezel off of here, because I want to be able to lift the clock assembly out to work on it. And I've also removed a screw in the back here, as I like to be able to remove the display and the clock from the actual base so that I can work on it. And I don't quite know how this thing comes out yet. There's got to be some more screws that hold this together that I'm just looking for right now. And there's more screws along the front here that hold, I guess it holds this chassis in place. I wonder if I take these out whether I'll be able to lift the whole, I just want to lift the clock assembly out. Creative use of black tape. Yeah, looks like these are all part of the chassis. And looks like there's one more back here. And hopefully the whole chassis will lift out now. Oh, one more. One more screw back here in the corner. Now the whole unit will lift out. Well, everything but the power supply down here, which you can see. Like, what rocket built this thing? Holy smoke. It's like, okay, 2 transformers down here and some capacitors. There's probably going to be 1 transformer for the radio and 1 transformer for the clock circuit, I would think. The clock circuit's all covered, it's all shielded here in this metal box. But if the voltages aren't correct, then the display is not going to work right. I mean, this is, look at this. This is all just wrapped up in black tape. Like who does stuff like this? This is probably factory original too. But you know, they just wrapped all the wires up with tape, and that tape is all now to this point where it's deteriorating. That's, I'm going to say, is a rechargeable battery. 1.2 volts. That'll be to maintain the clock in the event of a power failure. The clock circuit itself should just lift out from here now that I've got the chassis out. Now I can remove the clock circuit so that I can actually work on this. Here are the tubes themselves with the covers on them, and all the wires that go down to the tube sockets. And again, this is all shielded with a metal shield all the way around it. Now, they were taking no chances for interference for this, weren't they? Because I've never seen anything that's this well shielded. This is ridiculous. Here are the covers on each of the individual tubes, so we can see them all here. I guess to service the tubes, it should just unplug. Oh, there they are. They just unplug like that. They come pre-wrapped with this this coating. But let's take a look at the tubes themselves. And they've got a blue wrapper on them. They've got a blue filter, and then they've got this covering on them. But the nice thing about this is it can change the tubes around to see whether the problem is caused by a bad tube, because the tube on the left is obviously only going to display for the tens of hours. So if we swap that tube around with one of the other tubes, the other digits probably will be okay, because this tube here would not get anywhere near the amount of hours of emission that the other ones have. So if we swap a couple tubes around, we can rule out that it's the tubes themselves that's causing the display to be dim. And then we can go about measure some voltage. So it's going to make sure nothing's touching here. Reconnect up my cheater cord. I've got this shut off, by the way, now. Make sure nothing's going to touch, which was good. And apply power. And yeah, well, it's a little brighter. Not much though. But it could be the tubes. Take a look. This is a quick way to determine whether the tubes themselves, because the hours, minutes, and seconds tubes are sorry, the hours and minutes, there's no seconds on this, but the hours and minutes tubes are going to have roughly the same amount of hours on all of the segments, because they're running 24 hours a day. The tens of hours is only running on the times 10, 11, and 12. So the segments, we're only going to get 6 hours every 24-hour period versus the other tubes that are in operation 24 hours a day. So if the display brightness is caused by the tubes themselves being weak, now that I've put the tube that was in the tens of hours in the hour position, we should see the segments that are not related to forming the number 1 should be brighter. And they are, as you can see, right? The 2 segments that are weak are the ones over here. Now, we still could have a voltage problem. It's just that the tubes themselves probably are showing a little bit of age. So let's check the voltages and see how our supply voltages are to drive these tubes. Here's a look at one of the tubes with the wire mesh type covering. The screen that's on it's actually a mesh. It's grounded too, with the wire to the ground. But here's a look at the internal construction of the tube. You can see the 2 filament wires inside. Those are the cathode, and then the 7 anode segments. And these basically operate just like they would, these would operate like a diode tube. The cathodes are heated, they're emitting electrons, and then a positive voltage is applied to the plate. These ones don't have a screen. More modern vacuum fluorescent tubes actually had a screen in front of the actual phosphors, the plate. So basically how they operate is you've got a negative voltage on the cathode, which is also the heater. It's a direct heated cathode. So that's your negative voltage, and the positive voltage is applied to the anode, which is the plate at the back, which has got phosphorus painted on it. When you make the plate positive with respect to the cathode, electrons are drawn from the heated cathode and bombard the plate. And now what happens as these tubes age is that cathode wire that you see, the thin white wire that you see in the front, there's 2 of them. If I can illuminate it from another angle, you'll see the other one, but there's 2 of them in front of it, in front of the cathode or in front of the anode. What happens over time is that the coating that's on the cathode wire, which causes it to emit electrons when it's heated, the rare earth compounds that are on the cathode start to lose their efficiencies, and then the emission drops on the cathode itself, the filament. That's what happens when the tubes age. But a lot of other things can cause us to not have proper emission besides tube aging. Although this one I think is affected more by tube aging than probably anything else, because when I took the tube that had the least number of hours on it, the 2 segments on the right there are used to form the 1. The other segments are brighter than these 2. So I think that the tubes themselves are just getting a bit weak. But we got to check the voltages and make sure that the actual voltages to the tubes are correct. Make sure that there's enough filament voltage to heat the filament up hot enough to generate the electrons to begin with. Because if the filament's not warm, it's not going to emit electrons as efficiently as it should, and then you're going to have low brightness. So we have to do some voltage measurements here, which we can do right from the tube sockets, and that'll determine whether we've got a problem with the power supply that's supplying the tubes, or whether the problem is with the tubes themselves. Now these tubes normally are clear, and they've just been painted blue for this clock, but this is a Y1938 is the tube number. So we're going to look up a Y1938 and find out what the internal pinout is on this. So the pinout on a tube like this is, counting from the bottom, the filament is on pin 9 and pin 6. So there's 9, 8, 7, and 6. Filament, filament. Those are our filament leads. The rest of them are for the 7 segments. See what I mean when I say this thing is completely shielded? It's got a metal shield over here with an insulator underneath here, because the AC main power goes right into the side of this board. So all the high voltage stuff to power the tubes up is inside this shield container, which I'm gonna have to get in there to do any testing. There are a couple transformers down here. I believe these are probably the low voltage ones for the radio and so forth, but I don't have any service data on this thing at all, so it makes it a challenge, because I don't have any info on this at all. Okay, so first I need to remove the shield, so I'm just heating up my soldering iron here, and should be able to just take off a few. I think it's only held in place by a few. It's only held on by a few good connections. The rest of it was just the copper shielding that was soldered down, and it wasn't soldered down that well because it peeled off pretty easy. So if I get these ones hot enough, I should be able to just pop this base off, and then we can get the top cover off and see what's underneath this shield. Unfortunately, this is a pretty good heat sink, and it's taking a little longer to heat this up than I anticipated. I may need to get a bigger iron for this. Several minutes later, I have the shield off, now I can get the insulator off here so we can actually see what's on the circuit board. And again, they've just put black tape on here to insulate this thing. Now this obviously is going to be charged to mains voltage if I power it up, but we get a look at the circuit board here. I'm going to undo these other couple tabs here and lift the whole top shield off. I think it's only held in place in a couple places, one here and one over there, and then the whole top I think will lift off. So there's what's inside this thing. We've got this great big monstrosity of a capacitor here, 160 volts, 100 microfarads. We should check that one and see, first of all, what shape it's in. As I say, I think my voltage is a little low. I was only getting like 15 volts to my plates, and I think it should be a lot higher than that for these tubes. So that's okay. There's no voltage on there. Just want to make sure that there's no power on it before I start poking my fingers in. And as you can see, I mean, look at some of the wires on here are just, you know, their resistor here is touching up against this capacitor here. Yee, looks to be in pretty. Some of these wires look to be in pretty sad shape. But I have a sneaking suspicion that this cap might be starting to turn a little bit, go a little bit soft on it. We'll measure the voltage on this thing. I just want to see what it charges up to with no load. Just gonna make sure nothing's touching anything here. We'll clip the meter on. I just want to measure what voltage we're getting across this capacitor. Being a large cap with a 160 volt rating, I would expect that this thing's probably going to be charged up to a fairly good level. Negative and positive over here. Okay, let's see what this thing charges to. 41 volts. But you see, it doesn't hold the charge. It goes off right away. I just wonder if I bridge another cap across there, and we'll see what the voltage charges up to. Let's look at a bridge another cap. This one here is a 250 volt cap, 150 volt, 150 microfarads. Let's see what the voltage comes up to now. Yeah, 41 volts still. So maybe that's all it's really operating at is 41 volts, even though they got this massive 160 volt, 100 microfarad cap in there. I'm just going to go over a few of these. There's a few of these solder connections don't look too swift, like this one here. So I'm just going to go over a few of these and just touch them up a bit. And I think our problem on this is the tubes themselves, though, which is what I thought right from the beginning, that the tubes are going bad. Vacuum fluorescent displays, like all vacuum tubes, do have a limited life. And once they've reached that end of life, the emission starts to drop, and then it's all downhill. Now what we can sometimes do is increase the voltage across the filaments a little bit to heat the filaments up a little bit hotter, and that'll increase the emission. And that's about the only thing you can do on vacuum fluorescent displays. And it's about 1.2 volts across the filament, because you don't want enough voltage that will cause the filament to actually emit visible light, just enough to get it warm to emit electrons. So it could be raise the voltage to the filament slightly, could improve the outputs of these old tired tubes, or try to find some new tubes for it. That's ultimately would be the best solution, is to replace the tubes if we can find some new old stock tubes for these type of tubes, because they haven't made these things in years, right? So have to find some new old stock. Okay, what's interesting about this design, I've just traced the sockets. Pin 9 and pin 6 are the filaments. 9 and 6, these ones are parallel. The 2 hours ones are parallel together for 9 and 6. But if we trace them back here, they go to 2 separate wires. Pin 9 and pin 6 are on the green and the yellow green, or green with yellow stripe. And this one here is the brown, and the brown with the yellow stripe. And these two are on the blue with the yellow stripe. And if we look at this, these go to separate windings on the transformer. So the 3 tubes have 3 separate windings on the power transformer. And that's what delivers the filament voltage to the tubes. And they're fed AC on 3 separate windings. So not really having found anything obvious on the board that's at fault. I checked several resistors and so forth, and everything's measuring up to spec. So I'm just going to put the shield back on here, put the base on it, and start putting this thing back together. At this point, it's going to need the tubes. That's what the problem with it is the tubes themselves are just getting a bit weak. So it's got this paper shield that goes on top here. That's a little bit better. It's still going to be hot as hell, as I used a torch to remove the solder, as my little iron was struggling to heat this up. But I've got the metal pretty hot now. I heated it up with a torch, so soldering them back down won't be a problem, because the shield here is still pretty warm. Like the original, I'm wrapping it with a bit of electrical tape, and then the remainder of the shield goes on. I have to solder this down. So the unit's back as I received it, and it's still putting out about the same brightness as when I received it, other than the fact that I've changed the order of the tubes around. So this one here is now a little bit brighter. This is, I think, the one that was over here in the tens of hour display. Anyway, needs new tubes, so I'm going to end the video at this point. I'm going to put this thing back together and see if I can find some tubes for this. And if I get some tubes, we'll get some tubes in it and get it restored. So the unit just slides back in to the chassis. So you don't have to take it apart like this to change the tubes. The tubes can be all pulled out from the top without having to dismantle the whole radio. So the radio just drops back in here like that. I've got a couple screws in the front. We'll put the screws back in and then start putting the rest of the unit back together, and put it away until such time that we can find some tubes for this thing. Screws that are not magnetic, hate them. Like the screwdriver. I'm liking the screwdriver. It makes short work of putting these back together. Gotta like it. The radio is ready to go back together. The top goes on. It plugs in that interlock in the process of putting the top cover back on it, and 3 screws in the bottom. To hold the top cover on. The unit is back together, awaiting parts, if I can find the parts.
Guide you through 2,500 customizable styles. Our diamond consultants will ensure you create a ring that she'll love.
Nice.
You know what you want.
Yeah, the display is pretty dim. Anyway, till I can find a new set of tubes for that, thanks for watching.